The future of anti-aging medicine is expanding far beyond pharmaceuticals, moving into the realm of non-drug biotechnologies that enlist the body's own systems, especially the immune and physical repair mechanisms, to slow or reverse biological aging. These innovations represent a powerful shift in how we think about longevity interventions, not as a passive suppression of symptoms with drugs, but as active reprogramming and rejuvenation of tissues using targeted, systemic stimuli. One of the most compelling examples of this trend is the use of low-intensity pulsed ultrasound, LIPUS, a non-invasive technology that has been shown in recent studies to stimulate the immune system in a way that helps clear senescent cells, the dysfunctional, zombie cells that accumulate with age and drive inflammation and tissue degradation. In preclinical models, LIPUS appears to activate natural killer, NK, cells and macrophages, immune cells that are key players in the clearance of damaged or abnormal cells. The treatment involves delivering gentle, precisely timed acoustic pulses to specific tissues, which in turn generates localized biological effects, enhancing cellular permeability, altering inflammatory signaling, and attracting immune surveillance. In aged mice, repeated LIPUS treatments have led to improved muscle regeneration, reduced fibrosis, and enhanced physical performance, suggesting that such mechanical stimulation could become a routine anti-aging intervention. Future versions of this technology may be fine-tuned to target different tissues or cell types, offering a personalized tissue tune-up with minimal side effects or downtime. Similarly, the lessons of the COVID-19 pandemic have opened a powerful new chapter in immunological biotechnology. RNA vaccine platforms, originally developed for infectious disease, are now being explored as tools to train the immune system to recognize and eliminate senescent cells or other dysfunctional aging-related cell populations. These therapies use carefully designed mRNA sequences to express senescence-associated surface proteins or inflammatory markers, essentially teaching the immune system to identify and attack harmful cells that otherwise accumulate undisturbed with age. This approach could offer an elegant, self-amplifying way to clear damaged cells without the need for cytotoxic drugs or invasive procedures. Together, these strategies mark the emergence of a new anti-aging paradigm that is not chemical but bioactive, using energy, information, and cellular language rather than compounds to reshape the aging process. The appeal is enormous. Devices like LIPUS or similar modalities, such as electromagnetic fields, photobiomodulation, or transcranial stimulation, could be used intermittently, perhaps monthly or quarterly, to stimulate rejuvenation and immune maintenance. These interventions might eventually be available in outpatient clinics, wellness centers, or even home-based units, monitored by wearable devices that track physiological responses and optimize treatment parameters in real time. Immune modulation therapies, on the other hand, offer the promise of long-lasting systemic benefits. By selectively targeting age-associated immune dysfunction, whether through vaccines, engineered T cells, or checkpoint inhibitors adapted for aging, scientists could restore the immune system's ability to clear senescent cells, regulate inflammation, and maintain surveillance against cancer and viral reactivation. In a future scenario, individuals might receive periodic mRNA updates, much like software patches, that refresh immune targeting mechanisms in response to evolving cellular stress profiles. The result would be an immune system that not only defends against infection but actively participates in regeneration and longevity. As clinical validation grows, we may witness a convergence of these technologies into highly synergistic anti-aging protocols. A single treatment course might include LIPUS to stimulate local clearance of senescent cells, followed by an mRNA vaccine to prime systemic immune surveillance, combined with intermittent fasting or exercise to amplify autophagy and metabolic cleanup. These combinations could be customized based on age, organ health, genetic predisposition, and circulating biomarkers of biological age, delivered not by intuition, but guided by AI models and deep phenotyping. These non-drug biotechnologies also have the potential to democratize longevity interventions. While cutting-edge drugs or gene therapies may be expensive and logistically complex, physical modalities like ultrasound or vaccines could be scaled globally and delivered affordably. The accessibility of these tools makes them well-suited not just for wealthy individuals seeking life extension, but for public health systems aiming to extend healthy lifespan across populations. The result could be a meaningful compression of morbidity, where people not only live longer but spend far fewer years in decline or dependency. As we look toward the next decade, non-drug technologies will become increasingly essential in the anti-aging toolkit. These approaches challenge the outdated notion that aging must be addressed solely with chemicals or surgical interventions. Instead, they open the door to treating aging as a dynamic, interactive process, one that can be tuned, rewired, and supported through safe, repeatable, and precision-guided stimulation. With continued research and clinical progress, doctors of the near future may prescribe not just pills, but protocols involving immune-enhancing injections, tissue-restoring devices, and rejuvenation-inducing feedback therapies, all aimed at restoring the body's natural capacity to heal, regenerate, and thrive at any age.